Alright guys, we got rhombuses, rectangles, and squares today. I want to talk about a couple of these. A rhombus, that's going to be a parallelogram. All of these, by the way, are going to be parallelograms or specific cases of them. So it's a parallelogram where all sides are congruent. And there's a couple theorems we'll talk about in addition to that as far as all the sides are going to be congruent. So it's not just the opposite sides congruent, it's all four of the sides are going to be congruent. Alright, a rectangle, that's a parallelogram. With, I guess, four right angles. So that means all the angles will be right angles, or you could say all the sides are perpendicular to one another. Alright, and a square is a combination of the two. You're going to have right angles and all sides congruent. So four right angles and congruent sides. And then there you go. Alright, so there's a couple additional things that we'll talk about with these rhombuses here. So if you have a rhombus, the diagonals are going to wind up being perpendicular. So ABCD is a rhombus only if the line segment AC is perpendicular to DB. Alright, and then since a square is also considered a rhombus, that'll also be the same for squares. So rhombuses and squares. Alright, check this out. A parallelogram is a rhombus if each diagonal bisects a pair of opposite angles. So not only do we have this right angle going on here, these are going to be, the diagonals are angle bisectors. So we can say AC bisects the angle, I guess, DAB, and then DCB. And then BD bisects your other angle, ADC, and then ABC. Okay, so you got angle bisectors, and then you also have perpendicular diagonals. And once again, this also applies to your squares. Alright, now here's a special property of a rectangle. Parallelogram is a rectangle if and only if its diagonals are congruent. So we would say AC is congruent to DB. Alright, and what that makes is a bunch of little isosceles triangles inside of your shape. So then you can say that these angles here, so I guess what is that, CAB and ABD, those would be congruent since you have a bunch of little congruent miniature triangles. And that's also kind of used one of the properties of a parallelogram, that the diagonals bisect each other. So we're going to say that the diagonals are congruent and they bisect each other. Therefore, those little miniature pieces of the diagonals are congruent, making a bunch of isosceles trapezoids. Or not trapezoids, triangles, I guess. So, anyways, and that also applies to a square right there, since a square is technically a rectangle. I kind of like doing a flow chart here, so just to kind of show you all the different shapes that we've talked about so far. So this whole unit's kind of about quadrilaterals. Quadrilateral is four-sided figures. Now the ones that we've been talking about are parallelograms lately. and then you're going to have ones that are non-parallelograms. So we'll talk eventually about like your kites and your trapezoids. But we've been focusing on the parallelograms. So those break into two categories. You have rectangle and rhombuses. And then those kind of funnel back down into a combination of the two, and that's a square. So sometimes it's kind of nice knowing this little flow chart of how everything works and all the different categories, the broad ones and then the not so broad ones. So given the following parallelogram labeled properties, so we're just going to label like the things like you got parallel sides. We also have opposite sides are congruent. We know that the diagonals bisect each other. And then we also know that the opposite angles are congruent to one another. Alright, so there's all your properties. That's a parallelogram. And then you can extend those properties with rhombuses. Except now you have all the sides are congruent to one another, so I'll use one tick for all those. You have also this right angle. We know that the opposite angles are congruent and they're bisected. So all the little miniature angles are going to be congruent. Then you can also put that the diagonals bisect each other. And that is for your rhombus right there. So a little different. And then a rectangle is one of the new ones here we learned today. So you got parallel sides, obviously, because it's a parallelogram. Opposite sides are congruent. Then you have a bunch of right angles. I guess if you wanted to draw your diagonals, you can draw your diagonals. And we can say that they bisect each other and they're congruent. So then that makes a bunch of little miniature parts of your diagonals being congruent. And then a square, it's a combination of both of those there. So you got opposite sides parallel. You got all the sides are congruent. You got right angles at each one of your angles. If you wanted to draw, once again, your diagonals, they should bisect each other. And make a bunch of miniature pieces. And then also you have right angles inside. Here your diagonals need to be perpendicular to one another. And those are all of your different properties. So now I think we go and start using some of the stuff here. So for any rhombus RSTV, decide whether the statement is always or sometimes true. Draw a sketch. So I'm just going to draw a sketch of what this rhombus might look like, and then we'll kind of debate whether it'll be true or not. So pay attention to the order you have to go, either clockwise or counterclockwise in the order. So you have RSTV. And now we're saying S is congruent to V. All right, and since this is a rhombus, which is technically a parallelogram, I would say that this part here is true. Always, always, always opposite angles will be congruent inside of parallelograms. So I will say always. All right, now if we take that same figure and then determine whether T is congruent to V, notice that those are right next to each other. Now I can draw it in a certain way, actually. Could draw my rhombus like this, RSTV, to where all the sides are going to be the same length here. And if that happens right there, the only way that's going to happen where those are the same is if it's a square. So I'm going to say sometimes. If I draw it a certain way, I can make it work out, but not every single time. So we would say sometimes. So there is one example, but there's plenty of counterexamples. Okay, classify the quadrilateral right here. So I have 4 sides congruent. Since I have 4 sides congruent, I'm going to say it's a rhombus. That's pretty much it there for that one. Quadrilateral has 4 congruent sides and 4 congruent angles. Classify the quadrilateral. So the only way I can see that working out, 4 congruent sides and 4 congruent angles. Well, if the angles are all congruent, they have to be all right angles, and then 4 congruent sides. But the only way that's going to happen is if you have a square. Okay, a rectangle's got the 4 congruent angles, but it doesn't have the 4 congruent sides. A rhombus doesn't have the 4 congruent angles, but it has the 4 congruent sides. So square will be the best one there for that. The diagonals of a rectangle intersect at O, given that the measure of x, yw is 56. Okay, and they already marked that for us. And wy is 33. Find the indicated measures. So actually, what I'm going to do is wind up finding all the angles. Now, they told us, I think, that this thing's a rectangle. Yep. So we know that all of these angles are going to be 90 degrees here. If it's a rectangle, the little miniature parts of your diagonals bisect each other. So you have a bunch of isosceles triangles there. And then you can go back and figure out all of your different angles here. So I think 56 plus 56, oops, if I write it right, it'll be like 112, I think. And then subtract that from 180. And what does that get us? 68 degrees, I believe. Then you got vertical angles. Most of these angles are actually going to be kind of the same. Up here, you're going to have 112. If you want to find either of these 2 angles up here at the top, you can either use the 112, subtract it from 180, and then divide by 2. Or you can just do right up here 90 minus 56, and what's that going to be, 34 degrees, I believe. There you go. What else you got? Oh yeah, 34 degrees down here at the bottom. That would get you all of your angles there. So now we can go find them here. So let's see, W, X, Y. So that should be 90 degrees there. W, Y, Z. We found that to be 34 degrees since those were complementary. X, O, W. We found that to be 112. X, O, Y, found that to be 68 degrees. We have here W. I'm sorry, something's coming up on my computer. X, W, Y, that was also 34 degrees. X, W, Z, that was 90 degrees. Now we got to go find the segment lengths here. So WY, that whole entire thing was 33. So that means WO has got to be half of that. So you can just say, whatever, 33 divided by 2, whatever decimal that is. I think that's a hair more. It's 16.5, I believe. And then the other diagonal go in the other direction. We know the diagonals are congruent, so the other diagonal's got to be 33. And that's how you find all of your different side lengths and angles. The key thing with this, though, for the angles is just remember isosceles triangles, which means you're going to have a bunch of different congruent angles. All right. So, anyways, getting a little ESPN update there. It's nice. Diagonals of a square ABCD intersect at O, given that side AB is 5. Draw the figure and find the missing sides and angles. All right, so squares, these are a little tricky at first because people say, well, they don't give us any They don't give us any angles going on. But since we know that this is technically a rhombus, and then you also have right angles, that these little miniature angles here have to be the same, but then they also have to be 90 at the same time. So you're going to have a bunch of 45-degree angles. That's going to go on pretty much everywhere, all the way around the square. And then you're going to have a right angle there in the middle, because it's a rhombus technically. So there's all your angles, actually. And then your side lengths, let's see here, here I need to label my sides. So A, B, C, D. And then this side here is going to be 5. All right, and then actually, so you have a 45, 45, 90 triangle going on here. So if that side is 5, you have your A squared 2 side, your A and your A. So then you can go find those little miniature parts of your diagonals. So check this out here. That's going to be 5 equals A squared to 2. Divide both sides by square root of 2. That'll be 5. Oops. I guess 5 divided by square root of 2, and then you got to rationalize. So it'll be 5 square root of 2 over regular 2 for this little miniature side. So that means the entire side will be double that, so that'll actually just be 5 square root of 2 over 2 times 2, or just regular 5 square root of 2. So then we'll go ahead and fill in the rest there. So AB, I think they told us that, 5, BC, 5, CD, 585. AO, and I guess O is the intersection there. That's going to be your 5 square root of 2 over 2. BO, CO, DO, it's going to be the same all the way down. I'm just going to draw a little arrow so I don't have to rewrite that a bunch of times. All right, let's look here. ABC, that's 90 degrees. ABO, that's 45 degrees. AOB is 90 degrees. And then AOD is also 90 degrees. All right, let's see here. ADO, that should be 45 degrees. ADC should be 90 degrees. CBA, 90 degrees. And CAB should be 45 degrees. All right, so that's it there on the square. So those would generally be pretty much the same. The only thing that can really change is the side length, but as far as the angles, those should all be pretty consistent. All right, based off of the parallelogram, find, what are we doing? Choose the best name and then find the measures of the numbered angles. All right, so right now I see 4 congruent sides, so I know right away that this has got to be a rhombus. All right, and if this is a rhombus, remember opposite angles are not only congruent, they're bisected. So I can put 54 there. So that means you're going to put 54 for 2 and 3. All right, and then if you have 54 and 54, that means you can find angle 4 right here, and also angle 1. I guess they'll be congruent. So that'll be 108. So I think angle 4 is going to be 72, and then this other angle right over here, angle 1, should be 72 as well. And there you go. That's about it there on that one. Looking here at this one, I see a right angle here, and we're assuming that these are all parallelograms, by the way. So I see a right angle. I know for sure this is a rectangle. Guess there's not enough information to tell whether it's a square or not. Or actually, I can tell you it's not a square because that angle is 18. Squares, you have to have 45 and 45. So this is definitely a rectangle. So there you go, rectangle, 18 degrees. All right, so with rectangles, don't forget that the diagonals are congruent. Therefore, and also you got angle bisectors, or not angle, you got diagonal bisectors. So you have a bunch of isosceles triangles. So I can squeeze in a little 18 degrees right there. You could subtract that from 90 to find angle 1. So angle 1, what's that going to be? 72 degrees. Which also means this other angle down here is going to be 72. So I think that's what, 140, 144. So that's got to add up. So I think that should be 36 right there. You can put 144 there for angle 4. No, angle 3 should be 18 again. And there's all your angles. Another one here, I'm seeing a right angle, and it's a parallelogram, so it's got to be a rectangle for sure. If it was a square, that 106 would actually be at 90, so it's definitely a rectangle here. All right, and then we can go and then find the rest of the angles there. So if you do 106 there, we know all the angles inside of this mini isosceles triangle. And remember that we know that because it's a rectangle there. Those all have to add up to 180. So I'm going to subtract 106 and then divide that by 2. So that's 74 divided by 2. So that's going to be 37 degrees and then another 37 degrees. And then if you do minus 90 or 90 minus that, you're going to get 53 for these angles. And then you can just kind of work your way around. 74, 106, and then you're good to go. So just use basically what you know about your triangles, and then you should be okay. What we got here, 59 degrees, alternate interior angles, 59 degrees as well. It's a rhombus because you got 4 congruent sides. So we know we have angle bisectors, 59, 59. We know that these middle angles, if it's a rhombus, those have to be 90 degrees. So actually that's all you got to do there on that one. Let's see. So I know, I'm looking here, I see a 30, 60, 90 triangle, which automatically means with this big triangle that this last angle right here of the big overall triangle has got to be a right angle. And then if that's true, then this has got to be a rectangle. So we got rectangle, which means many isosceles triangles. So you got 30, 30, that's 60, so you got 120 here. Which you didn't necessarily need that there. And then you got 60, so then this last angle's got to be 60. Actually, I have an equilateral triangle there to the right-hand side. All right, last one here. They give us that 2 consecutive sides are congruent. And then also this thing has to be a parallelogram. So actually, in this case, since the 2, we already know that the opposite sides are going to be congruent. And then you have 2 consecutive sides, so this thing has to be a rhombus. So you have a rhombus there, right angles in the middle. What do we got? 68. So angle 2 over here is going to be 68. To find that angle 1, remember all angles inside of a triangle need to add up to 180. So you could subtract 68. Actually, angle 2 and angle 1 need to be complementary. So we can say that this is 22 over here by 1. And those angles right next to each other, those are bisected. So angle 3 over there should be 68, and that would be a rhombus. All right, a couple more here. The diagonal of the rhombus of PQR has intersected T, given that angle RPS is 30 degrees. And RT is 6, find the indicated measures. So a rhombus, got 90 degree right there. So this last angle's got to be 60, and then you can go find the rest. 60, 60, 60, 60, 30, 30, 30. What do they tell us also? RT, where is that? Oh, okay, RT is going to be 6. And I bet you we're going to have to use a 36 and 90 triangle to find the rest. All right, let's see here. You got Q, P, and then R. Where is that? QPR. Oh, okay, yep. So that's 30 degrees right there. This is the angle bisector. And then you got QTP, which that should be a 90 degree angle. And then we're going to find RP. So if half the diagonal is 6, then the full diagonal has got to be 12. And then TS. And then this is where, so we need to find this side right here, TS. And this is where we're going to use our 30, 60, 90 triangle. So we have 6. We have 30 degree angle. So we're going to find this side here. I guess I'll call it X. That's X. Then you have X root 3 and 2X going on. So we'll say 6 equals x squared root of 3. Divide both sides by square root of 3, and then rationalize. And if you need help with some 30, 60, 90 triangle stuff, a couple of units ago, you can check that out. So the little half side there is 2 square root of 3. And you're done there. Alright, next one, got a rhombus. So I'll say W, X, Y, Z. So X is this 24, which I'll have to distribute to 10 minus X. And then the angle Z is 6, and then X plus 15. Alright, so since it's a rhombus, since that's technically a parallelogram, we're going to set those equal to each other. Let's make that look a little bit better. Alright, so distributive property there, 240 minus 24x equals 6x, and then plus, I think that's 90. It is. And then we'll add the 24x, you'll get 30x on the right hand side, and then subtract the 90, which you should get 150 there. So then x will be 5 at the very end. Now if I know x is 5, then we can go plug them back into either one of those angles. That one looks a hair easier to me. So that'll be basically 5 plus 15, that'll be 20, and then that'll be 120 once you multiply by 6. So it means you have 120, 120. Remember, the consecutive interior angles need to be supplementary, so then angle W and angle Y must be 60 then after that. And that's all you do there. So there's a couple of problems there on that. These are a little tricky sometimes, the always, sometimes, or never. Essentially, we're looking for counterexamples. If we can find a counterexample, most of the times we'll be able to put like sometimes. And then, yeah, we'll just see if, if we can, then it's either always or never. So let's see what we got here on this one here. All angles inside of a parallelogram are congruent. Now, you can draw a certain parallelogram where they are all congruent. And those would be either a rectangle or, more specifically, even a square right there. So I'd say sometimes. There's a way you can draw it where they are congruent, but generally when we think parallelogram, we don't think of all angles being congruent unless it's a specific case. I'll say sometimes for the specific case. All right, look at this. A rectangle is a square. So this one right here, I would say, again, on this one right here, I would say sometimes I can draw a certain rectangle where it has 4 right angles. I can draw it in a certain way to where I make it look like a square. So that's the part that's kind of confusing. So think about, if you draw a rectangle in a very specific way, could you make it look like a square? And I say, yes, you can. There is one way you can do that. Now, a square is a rectangle. So any square I ever draw, it should have the properties of a rectangle. It should have the 4 right angles, and it should have the diagonals congruent. So I'm going to say always in this case. And it's kind of good. It's useful to go back and look at that little flow chart that we made back here at the very beginning. A square is always a rectangle. So that kind of will help us out there. But a rectangle doesn't necessarily always need to be a square. It could look like a square, but not always. So that's why we put sometimes on that previous one. The diagonals of a square are perpendicular bisectors of each other. Well, since this is a parallelogram, in parallelograms, the perpendicular bisectors, you have the diagonals bisect each other, and then a square at the same time is a category of a rhombus, which those are perpendicular to one another. So I would say always for this one. You won't be able to draw it any other way. The diagonals, this one's kind of a tricky one here. If the diagonals of a quadrilateral are congruent, then it is a rectangle. And a lot of people want to say always because they can't really think of any other shape that is a four-sided figure where it could happen like that. There's actually a specific case. We're actually going to get into it quite a bit, I think, in the next day. It's called an isosceles trapezoid, if I can draw it well. So that the diagonals of an isosceles trapezoid, meaning that the two legs of the trapezoid are the same. That one, the diagonals will be congruent. So I would say sometimes on this one. And that's kind of a tricky one there. It's one where you got to think a little bit outside of the box there. So kind of tricky. All right, can you conclude if the parallelogram is a rhombus, a rectangle, or a square? So it looks like we are assuming it's already a parallelogram. Therefore, is it a rhombus, rectangle, or square in addition to a parallelogram? So looking at this first one here, I noticed that the angles are bisected. So I know that's a property of a rhombus. So that's really all you do there. It's a parallelogram, got angle bisectors, got to be a rhombus. Okay, with this one here, they say that the sides are parallel. Of course they are because it's a parallelogram. But they don't really tell us anything else. It looks like a rectangle, but nothing else is marked. So I just say nothing's marked. So we can't conclude any of the others there. Now look at 16 here. You got perpendicular line right there. The diagonals are perpendicular to each other, so this has to be a rhombus. There's nothing else to indicate to us that it could be a square. So we'll say that right there, rhombus. And then last one here, NP and OQ are congruent. So where's that? NP and OQ. So that means your diagonals are congruent. That's a property of a rectangle. And not a square because they didn't tell us anything else. All right, and I think that is it for our lesson.